Hello. In this video, I wanted to cover a topic that has intrigued me ever since I went into more advanced mathematics within college. Effectively, I was reflecting back upon algebra that I used to do in high school, and I realized that within that algebra, there is a hidden reversibility. And the reversibility actually explains how algebra actually works. So in this video, I want to share with you the hidden reversibility within algebra. I hope this gives you a better understanding of how algebra works, and I won't be making any assumptions about any background. This video is intended for students who are in their early stages of learning algebra, and you don't need to know any advanced mathematics. Just come in with an open mind and your logical thinking. Let's begin. So, you may have seen a problem like this in your algebra class. 5x plus 2 is equal to 10. This is an equation. And in this case, x is just a variable. It's a symbol that isn't assigned to any value, just an empty name being weighted to assign to something. Now, the goal is to find a real number solution for x. We want to find a real number that we can assign to x this name without an object, such that this equation becomes true. So for example, for x, we could assign the number 1. And if we assign the number 1, well, then we get 1 plus 2 is 3, and then 3 times 5 is 15. And 15 is not equal to 10. So that makes the equation false. But the idea is we want to find a real number that when we assign to x actually makes the equation true. So how do we do it? Let's start with this phrase. Let x be a real number. Now this is a phrase that a lot of mathematicians will use within their proofs. But it actually has a really simple meaning. It just means pretend that x has been assigned a real number. We can play pretend, right? A way I like to think about this more concretely is I like to think of it as I had a friend who goes out and chooses a real number, maybe randomly, maybe with some choice. And he puts that real number in a box and hands it to me. And I take the symbol x and assign it to whatever's in the box. Then I can think of x as having been assigned a real number, but I don't know which real number. It's just assigned to one of them. So that's hopefully a concrete way that you can think and play pretend. So now that we're pretending here, statements like 5x plus 2 is equal to 10 and x is equal to 15, under this pretend belief, they become either true or false. If x is assigned 3, then 5x plus 2 is equal to 10 is either true or false. If x is assigned 3 here, then x is equal to 15 is actually a false statement. But the idea here is that x Well, we don't know what it's being assigned. So right now, while this and this equation are true or false, we don't know which is which. So we have our equation, 5x plus 2 is equal to 10. And, we don't know if it's true or false based on what x is assigned to it. But let's assume it's true. I've kind of labeled that here. So we're assuming it's true. So we can say it, 5x plus 2 is equal to 10. And let's see what true statements we can derive from this. And our goal is to get x by itself. And you'll see why this is so useful later on. Well, we can divide by 5 on both sides, right? We have this is equal to this, right? So if we divide 5 on both sides, that won't make them suddenly not equal. So we do that. And then we get rid of the 5. And we do 10 divided by 5 is 2. So that's great. And in the same vein, like we divided 5 on both sides, let's subtract by 2 on both sides. We should get another true statement. We do that, and then we get x is equal to 0. So from this true statement, or at least what we assumed is true, we get this true statement. So this is kind of summarized here. Assuming that 5x plus 2 is equal to 10 is true, we get that x is equal to 0 is true. Now just remember, this is an assumption. We don't actually know if this is true and this is true. It depends upon what x is assigned to. Remember, we're playing pretend here. X is assigned to a specific but unknown number. But what we have shown is quite cool. We have shown that if we assume this is true, then we somewhat magically get that x is equal to 0 is true. It's not actually magic. We went through very, very precise steps along the way. But I like to think of it almost like magic. But what if we assume that 5x plus 2 is equal to 10 is false? Does that give us any information about whether x is equal to 0 is true or false? Well, not yet. Nothing in our analysis so far has allowed us to say, hey, x is equal to 0 is now true, or x is equal to 0 is now false, under this assumption. Well, this will change. The foreshadowing commences. All right. Now, we actually want to go in the reverse direction. This video was titled with reversibility, right? I had to go in the reverse direction at some point. And in particular, we're going to start with this equation, and we're going to see if we can actually get back to this equation. So let's assume that x is equal to 0 is true. So we're assuming it's true. We can say it's true. And let's see what true statements we can derive from it. Well, if x is equal to 0 is true, then we can add 2 on both sides, so we can do that. And then, well, we have this is equal to this, so if we multiply by 5 on both sides, that should be okay. That would result in a true statement. So we do that. And then, well, we just simplify here, and we get that. So under this assumption, we get this true statement. Summarized here. Assume that x is equal to 0 is true. Then we get that 5x plus 2 is equal to 10 is true. So we assume that this is true, and we magically, or not so magically, get that 5x plus 2 is equal to 10 is true. Now, we were able to start with this being true, and we got this is true. We started with this as true, and we got this as true. Can we use that in order to figure out what happens if we assume that this is false? What will this say about this case? Turns out we can. So I brought both of those pieces down here. One piece here, one piece here. Now, if we assume that this is false, what does that say about x is equal to 0? Well, we know that when x is equal to 0 is true, 5x plus 2 is equal to 10 is true. So we know that if x is equal to 0 happened to be true, then this should have also been true. However, this is not true. This is false. So that means that x is equal to 0 cannot be true. The only possibility is that it has to be false. If it's not true, it's false. There's no in between, remember? So that is quite magical. Going in the reverse direction was so crucial because it allowed us to solve this question. If we assume the first thing is false, what's the truth value of the second thing? Well, it's false. Now, using this knowledge, we can actually rule out some cases. So 5x plus 2 is equal to 10, and x is equal to 0. Again, we don't know whether they're true or they're false. We've just been analyzing what was true and what is false under what assumptions. But in general, we know that there are 4 possibilities. Either both are true, or both are false, or one is true and one is false, or vice versa. Well, can we rule out any of these cases? My purple lines might give away the answer, but let's try to logically reason through it. Well, we know that when 5x plus 2 is equal to 10 is true, we know that automatically x is equal to 0 is true. So this case, nothing wrong with it. We also know that when 5x plus 2 is equal to 10 is false, we know that x is equal to 0 is false. So nothing's wrong here. But when 5x plus 2 is equal to 10 is true, we established that x is equal to 0 must be true. But we have false written here. This is not a possible solution. This cannot happen. And vice versa, if this is false, we know that x is equal to 0 must be false. But it says true here. So this cannot happen either. We know that 5x plus 2 is equal to 10 and x is equal to 0 are either true together or false together. They're the best of buddies. They're equivalent. Okay, so we've seen the reversibility. We've seen that the truth values of these two equations are the same. But how does this help us answer our original question? What is the solutions to the equation 5x plus 2 is equal to 10? Well, let's get to it right now. Remember how at the very beginning we played pretend? We said that let x be a real number. Pretend that x is assigned to a real number. And how does that help us? Why did we do that? Well, the reason we did that is because then throughout the proof, we assumed that x was assigned to some specific yet unknown to us real number. That forced us throughout the proof to not think of x as any specific number, and we only used properties that apply to all of the real numbers. Basically, in short, the logic of our proof applies no matter what real number was actually assigned to x. So we can actually use this to our advantage. Well, I've written kind of what we had from what we had here. And the idea is that if you assign x to any number of your choice, for example, x is assigned to 3, this will still hold. Either both statements will be true, or either both statements will be false. I hope that makes sense. Now, let's use that to our advantage. Because now we actually have the power. We can assign to x things of our choosing. And we can actually assign to x things that make the equations true or false. Now, for example, let's assign 4 to x. We know if we assign 4 to x, then either both expressions are going to be true or both expressions are going to be false. And we actually know that if we assign 4 to x, well, of course it's going to make this second equation false. 4 is not equal to 0. And because this is going to be forced to be false, we know that we're living in this world right over here. This has to be false. So we know that 4 is definitely not a solution to this equation. Basically, all we need to do is find all the solutions to this equation. And by finding all the solutions to this equation, we automatically find all the solutions to this equation. And this equation is super easy to figure out what are the solutions to it. There's only one solution. And that is if we assign x to be 0. That's the only real number that when you assign to x, that will make this equation true. And it will make this equation true and automatically make the other equation true. So not only is 0 a solution to this equation, it is the only solution to this equation. All numbers other than 0 assigned to x would make x is equal to 0 false. And consequently, it would also make 5x plus 2 is equal to 10 false. So just a quick recap. We started with our question. We wanted to find a real number solution for x. 5x plus 2 is equal to 10. We played pretend. We let x be a real number. We pretended that x is assigned to a real number. Then we kind of went in one direction. We assumed that 5x plus 2 is equal to 10, and then we got x is equal to 0. And then we went in the other direction. We started and assumed x is equal to 0, and then we got 5x plus 2 is equal to 10. The reverse direction was so crucial. And then once we did that, we basically used some logical reasoning in order to figure out what numbers assigned to x actually make x is equal to 0 true. And the only number that assigned to x that makes x is equal to 0 true is 0. And that's consequently the only number that also makes 5x plus 2 is equal to 10 true as well. So thanks for watching. And just to leave you with a quick practice problem so you can try out the methods that I mentioned today, try this problem. Find a real number solution for x. 2x plus 15 is equal to 3x minus 10. And make sure to follow the same logic I showed above. And hopefully that should give you some incentive to really deeply understand the steps I provided above in case you haven't already got them. So thank you so much for watching, and I hope you now are familiar with the hidden reversibility within algebra.